Hi everybody, today we are going to learn algebraic expressions and we are going to learn some basic mathematical operations in algebra. Before that, let's quickly recap what did we study in the last one. In the last tutorial we understood the concept of constants, variables, terms of an expression, factors of terms. So we've learned factors of numbers, but we also learned factors of algebraic terms, coefficients, like and unlike terms, and polynomials. So we basically did the basic concept building of algebraic expressions. Today we are going to learn addition and subtraction. How do we add and subtract? Value of an expression. I've already covered it in my grade 6th algebraic expression tutorial as well, but we will just quickly do it. Number patterns expressed in terms of algebraic expressions. Okay, we have done it as well in while studying even numbers, odd numbers. Multiply and divide. So how to multiply and divide algebraic expressions? Rather simple. So I plan to finish quickly, so keep the pace up. Okay, let's start with the addition and subtraction. So basically you can add like terms and you cannot add unlike terms. Similarly for subtraction. Okay, so like terms, if the terms are like, you can add or subtract. So for example, let's say if we have to add these two, okay, right here, 3x plus 11 plus 8z plus 7x. So what we do is that the easier way of doing it is that first of all we rearrange it. Okay, we write it vertically, horizontally. Then the second term, if I have to add this to this one, what I will do is that I will pick up the first term and see where is the like term. So I see that the like term is here, because so I will put 7x here plus, do I have anything as multiple of z? No, I don't. So I will put a 0 here, and yes, I do have a constant, so plus I will put minus 5 here, and then right, so I will put minus 5 here, and then I will just do an addition. Simple. So what is it? 11 plus minus 5 is 6, right? 8z plus 0 is 8z, and 3x plus 7x is 10x. So that's my answer. Very simple. That is the way you should do it initially. After you have built in some practice, then no need to arrange it. You can then initially you should do this so that you do not miss out on a term. Once again, I have to subtract this expression from this one. So let's write this one first. It's 30 AB plus 12B plus 14A. So it's a trinomial, and I have to subtract 24AB. So I write 24AB here. Okay, minus 10B. So I write minus 10B here, minus 18A here. But my operation is of subtraction. Okay, whenever the operation is of subtraction, whatever is the sign that you will see of the terms in the algebraic expression that you are subtracting, you have to reverse the signs. Okay, so basically here it is, right now it is plus, because so this will become minus, this is minus, so this will become plus, this is minus, so this will become plus, and then we just do the basic addition. Okay, so it is 32a, okay, plus 32a, this is 22b, right, and this is 30ab minus 24ab now. Okay, this is 6ab. So that's my answer. Now you ask me that why did you reverse the signs? It's very simple. If I were to write it horizontally, okay, this is my expression minus 24ab minus 10b minus 18a, right? Now when I open it, and we have discussed this in integers, okay? So I open it, so minus plus, this is a plus, right? So minus plus is minus 24ab, minus minus it opens as plus 10b, minus minus it opens as plus 18a, right? And we have discussed this already, because we are subtracting a negative term, so it becomes positive. Here also it's a negative term, we are subtracting it, so it becomes positive. It's a positive term that we are subtracting, so it becomes negative, which is why we reverse the sign. So the principles of addition is not going to change. It's just that instead of integers, we are adding or subtracting algebraic expressions and like terms from like terms, okay? Just a practice sort of a thing. From the sum of terms this and this, subtract the sum of this. It's fairly simple. Let's do it. 2y square plus 3yz. Okay, we have to add first these three. Minus y square. Do we see a y square? Yes, we see. So we put minus y square here. Minus yz. Yes, there is a yz here. Minus z square. Is there a z square? No. So we will write it separately. Okay. Then yz plus 2z square. So yz I will put here, right? And then plus 2z square I will put here. And then I will add. Wherever there is nothing, I will put a 0, right? So this becomes 3z square. This yz cancels out. It becomes 3yz. And this is 2y square minus y square. So that becomes y square. So that's the expression which I get. Okay. So my final, I have added it. And the expression which I have got is y square plus 3yz plus 3z square. That's what I've got. Okay, now subtract the sum of 3y square minus z square and then minus y square. So minus y square I will put here. There is no yz in this one, so I will write it separately, yz, and plus z square. So that's right here. Okay, and I have to add. Cancels out. This basically is 2y square and this is yz. Now I have to subtract this from this. Okay, so let's find out where is 2y square. Let's take it here, 2y square. Yz I will put it here, plus yz. There is no z square term here, so I will put it as a 0. You can, after you have practiced, then you can just straight away see and start calculating. We have to subtract, so this is a plus, basically it will become minus. Let me use a different color. This will become a minus, minus, minus. So 3z square minus 0 is how much? It is 3z square. Y square minus 2y square is minus y square. 3yz minus yz is plus 2yz. So that's my answer. Okay. Find the value of the expression. Like I said, see, algebraic expressions, they have variables. This expression is 100 minus 10x cubed. Now, as I change the value of x, let's say x is equal to 0, the value of the expression will be 100, right? If I put x equal to 1, the value of this will be 90, because 100 minus 10 into 1 into 1 into 1, right? If I put x equal to 10, right, its value will be 100 minus 10 into 10 into 10 into 10. So it will be 100 minus 10,000, which is 9,990. So as you can see, depending on the value of x, the value of the expression is also changing, right? And that happens for algebraic expressions. Now these are number patterns. So we already had discussed it. Algebra gives us the benefit of expressing number patterns. So for example, any even number, it can be expressed as 2n. We have already discussed it. Because what are even numbers? 2, 4, 6, 8, 0, any number that ends in these numbers, and all the even numbers are basically divisible by 2. So if I write an even number as 2n and divide it by 2, I know that there is a common factor of 2 in there somewhere, right? And hence, irrespective of what the value is n of n is, 2n will always be an even number. Yeah? And which is why now odd number, I can represent odd number as 2n plus 1, because any number you just add 1 to 2n, even number, and you get an odd number, right? Another way of looking at an odd number is also 2n minus 1, right? Because a number which is also 1 less than a even number will also be an odd number. Similarly, a number 1 plus than an even number will also be an odd number. So these are number patterns. Algebra gives us the benefit of expressing them. Multiplication and division, let's pick up x square plus 3x as one expression, and y plus 2x as a second expression, and I have to multiply. Now see, the way algebra multiplication works is that you have to multiply it like the distributive property. Okay, so we take either this term as constant, and then we distribute the multiplication over however number of terms are here, which means I will break it down as x square plus 3x into y. Okay, and then I will say x square plus 3x into 2x, right? And then what I will do is that now here I have a single term, here I have a single term, it's a monomial. What I will do is that now I will once again multiply it over the two terms here, and I will make it x square y plus 3xy plus this is 2x cube plus 6x square, and then I will simplify it so that all the like terms are, but here I see that all of them are unlike terms. So that's how we multiply. Now let's say if there were to be another term here plus xy, then I would have added another x square plus 3x, okay, into xy. Okay, so now I would have also expanded this one, which would have made it x cube y, okay, plus 3x square y. So now I see that I have generated 3x square y here and x square y here, so I should add these two, and it will become 4x square y plus, and I will suggest that you either circle it or underline it so that you know only these terms are remaining, and from these terms then you will have to look for the like terms. Okay, so this is 3xy plus 2x cube, right, plus x cube y plus 6x square. All of them are unlike terms. This is the answer if I add another term xy to the second term. So that's how we multiply. For division, basically for division, what it is even simpler. See, understand that for division what happens is that we have to factorize it first, x plus 2 into something like that, and if I have one of the factors in the as divisor, x plus 2, then obviously x plus 2 and x plus 2 will get cancelled, and I will get x plus 3. Okay, so my actual question would be x square plus 2x plus 3x plus 6, which basically is x square plus 5x plus 6. Okay, you divide it by x plus 2. So in order to for you to be able to divide, you will need factorization of algebraic expressions. Okay, so for now just understand is that if you already have it in terms of factors like this, then you can simply divide and take out the factors. It will not so happen is that x square uh, will be divided by x, or 5x will be divided by x, and 6 will be divided by 2. No, you have to break it down as product of algebraic expressions, and if the algebraic expression or algebraic factors are common factors are there, then you should be able to cancel it out. So in order to learn division of algebraic expressions, we will need to learn factorization, which I will cover in the next tutorial whenever I make on algebra. So till that time, just hang on with this broad idea. I hope you enjoyed it, and many thanks for watching the video, and I will see you in the next tutorial. Take care.